Hello students, welcome to my channel. So in our previous class, we have discussed on the versatile nature of carbon and also discussed on saturated and unsaturated compounds of carbon. And in today's class, we will understand the structure of carbon, in what structures they are formed. So if you have observed a chain would be linked one after the other in a sequential order, one after the other linked together. So carbon compounds also form their structures. It could be a small molecule like methane, then a medium sized molecule, and also large compounds that they form. So they come in the form of a chain, straight chain. If you have observed a tree has many branches and it is spread out like this, right? A tree just spreads out, giving many branches. So these carbon atoms come together and form molecules to form their compounds in the same manner. So they are formed in the form of a branched structure and also in the form of a ring-like structure, like something like this, which we will discuss with examples. So ring shaped. So just understand this, that carbon compounds are formed in different forms, in different structures. They could be in the form of a chain, they could be in the form of a branched structure, and they could be in the form of a ring. So let us understand this further. So in our previous classes, we have discussed on the simplest carbon compound, which is methane. So CH4 is methane and its structural formula would be so this is methane. So another example which I gave in my previous class about ethane. So ethane is C2H6. So the structural formula, okay, just make some space here. So this is ethane. Okay. Another carbon compound which is propane, and the structural formula. So carbon atoms come together and they form bonds, they link up together and they form carbon compounds ranging from small carbon compounds to medium sized ones and also big sized carbon compounds. So you can have a look, right from small, the simplest carbon compound, which is methane, and then it becomes bigger, which is ethane with 2 carbon atoms, and propane with 3 carbon atoms. So this is how the chain works, right from small molecule, from small carbon compound, it goes up and it becomes big carbon compounds. So let's have a look at the bigger chains. So butane, which has 4 carbon atoms, 10 hydrogen atoms. So the structure 1, 2, 3, 4. So this is the structure of butane. Another example is pentane, which would be 5. So children, pentane is nothing but 5. Remember this pentagon in geometry, which is having 5 sides. So pentane is nothing but 5 carbon atoms. So not required to memorize this, just split the word, you will remember it. So that is the structure of pentane, and it goes on adding, and then there's hexane with 6 carbon atoms. So now we have had a look at methane, ethane, propane, butane, pentane and hexane. So it's nothing but the carbon atoms just keep on adding. So just remember, when there is 5 carbon atoms, it's pentane. When there is 6 carbon atoms, it's hexane. When there is 4 carbon atoms, it's butane. And 3 propane, 2 ethane and 1 is methane. So children, let us understand the structure of butane. So this is the structure of butane, and now what I'll do, I'll just rearrange it. So we will not change the molecular formula because butane molecular formula is C4H10. So it consists of 4 carbon atoms and 10 hydrogen atoms. So we'll just little change the structure, we'll just rearrange it. So 1, 2, so this is the skeletal structure of carbon. I've just arranged it, rearranged it, and now we will fill the valency of carbon. So you all know carbon valency is 4. So we'll fill up this with the hydrogen atoms. So not to get confused, like I explained in my previous class, just do it systematically, step by step. So carbon atom is linked up here, 1 bond. So its valency carbon is 4. So 1 is already, it is linked up, it has shared 1 electron with the neighboring carbon atom. So 3 are remaining. So I will add 1, 2 and 3. So 1, 2, 3, 4. So the valency is satisfied. So we'll go to this carbon atom. So only 1, whereas the valency is 4 of carbon. So 1, 2 and 3. So done. 1, 2, 3, 4. 4 electrons are bonding with the atoms. So this carbon atom 1, 2, 3. So 4 valency, 3 are being shared, 1 is remaining. So make a bond here, hydrogen. So this is not complicated, just use your basic logic. This is just understanding, don't memorize things. So this carbon atom, it is shared 1 electron, we have to satisfy its valency. Valency is 4, so minus 1, 3 are remaining. 1, 2, 3. So the valency of all the 4 carbon atoms are satisfied. Now look carefully at both the structures. You can see both the structures. So observe carefully, both of these structures have the same molecular formula, which is nothing but C4H10. Both of these structures have the same number of carbon atoms and the same number of hydrogen atoms. Both have the same molecular formula, which is nothing but butane. But the structures are different. They look different. One is a straight chain and one is branched. So such compounds, carbon compounds, which have the same molecular formula but different structures, are nothing but isomers. Remember this, it is important. Carbon compounds having the same molecular formula but different chemical structures are nothing but isomers. So I have explained this with this example. One is straight chain, the other is branch chain, but the molecular formula is same. Both are same, both are butane, but they are isomers. They have different structures. Now let's have a look at another structure. So split the word if you don't understand, or if you want to remember it, memorize it. Cyclo is in the form of a ring, cyclic, and hexane is nothing but 6. So cyclohexane, which has 6 carbon atoms, and C6H12. That's the formula, molecular formula. So let's fill up the valency of carbon. Okay, so 2 and the valency is 4, so I will add 2 more atoms. So do all of this in stepwise procedure, like I've explained in detail in my previous classes. So don't memorize the structures, it will become very difficult and it seems to be complicated and difficult. So just understand, use your basic logic, basic understanding is required. So cyclo means cyclic, ring shaped. Hexane is nothing but hexa is 6. So 6 carbon atoms. So draw 6 carbon atoms, link it with the single bond and then start filling its valency. So this is the structure of cyclohexane. And carbon compounds, like I mentioned, they come in the form of a straight chain, branched, which we already discussed, isomers, and also in the form of a ring shaped. So now let's have a look at this carbon compound, which is benzene. Formula C6H6. So formula, you need to memorize it. Six carbon atoms. Link it with a single bond, like I explained, and start filling hydrogen atoms. So 6 hydrogen atoms. 1, 2, 3, 4, 5, and 6. So it's complete? No, it's not complete. There's another step remaining. Step 4. Step 4, which is check for the valency. The valency has to be satisfied. So carbon valency 4, where it is bonding only with 3 atoms here. So one more electron remaining, which forms a double bond. So here also it forms a double bond. So by now you all should get clear picture of this concept, because I have explained all of this in detail in my previous class. So if you have not checked my explanation, then you can check my previous classes. So this is the structure of benzene. So by this you should understand that carbon compounds form structures in the form of a chain, in the form of branched, and also in the form of a ring, which is cyclic, and they could occur in either by forming single bonds, double, triple bond. So carbon compounds form molecular structures in the form of a straight chain, branched, and also ring shaped, and they form single bond, double bond, or either triple bond. And carbon atoms, when they link up with hydrogen atoms, when they form bonds, hydrogen and carbon together, they are nothing but they are called hydrocarbons. So hydrogen, which links up with carbon, they form bonds. They are nothing but they are called as hydrocarbons. So among these hydrocarbons, they are given names, just like how you and I have names. So they also are given names, these hydrocarbons. So if there are single bond which is saturated carbon compounds, then they are called as alkanes. I gave you all so many examples in my previous explanation. Alkanes, if they have double bond carbon compounds, then they are called as alkenes. And if they have triple bond, then they are called as alkynes. So children, remember this: hydrogen coming together with carbon, both becoming friends, and they form compounds, they form big molecular structures in the form of chain, branch, and ring shaped structures. They are nothing but they are called as hydrocarbons. And these hydrocarbons, if they have saturated bonds, then they are called as alkanes, double bond, then alkenes, triple bond, then alkynes. So just split the word, don't get confused. So if it has this, it is saturated. This is double bond and this is triple bond. So by the name itself, you can understand the compound. So children, so far we have studied that carbon atoms, they link with hydrogen atoms to form hydrocarbon. So they form these compounds, but carbon not only links up with hydrogen, they not only become friends with hydrogen, but they also become friends with other elements like halogens. So why should carbon atoms only link up with hydrogen atoms? So if they have the opportunity, then they do make friendship with other elements, they become friends. Halogens, sulfur, nitrogen and oxygen. So now let us understand that I'll give you all an example of methane. So suppose carbon atom wants to make friendship with a halogen, which is chlorine, then it would look like this, right? So this is methane, CH4. This is the structure. So when it wants to make friendship, it will bind up with another element, which is an halogen. In this example, a simple example, most basic carbon compound I've given y'all, which is chlorine, and they form chloromethane. So remember that the valency is not disturbed, it is satisfied. It is just that it is replaced with another element, where here all three are hydrogen atoms. So the valency would remain the same, it would be satisfied, and this element which links up with this carbon compound, it is called a heteroatom. So heteroatom it is called, so we'll split the word to remember. Hetero is nothing but dissimilar, so it's not the same, it's dissimilar, something different. So this element which bonds with carbon, it's called a heteroatom, and this heteroatom, or the group that it belongs to, that attaches to this carbon compound, that confers the properties of the carbon compound regardless of the nature and length of the chain. So remember that even if this is having 2 carbon atoms or 3 or multiple, maybe 4, 5 carbon atom chain, and there would be only one heteroatom, the properties will be similar. So heteroatom, the element or the group which gets attached to the carbon compound, confer the properties of the carbon compound regardless of the nature and the length of the carbon compound, the chain length. So let us understand few more examples of this. So the functional group halogen, nothing but chlorine and bromine. Then alcohol, OH. So it is called the functional group because irrespective of the length of the carbon compound or the nature, the properties that it confers remains the same. So that's why it is called the functional group. Aldehydes, so here are the functional groups, and here are the formula. If you observe here, there are single lines. So this is nothing but free valency or valencies. It is through this that the functional group, the entire group, gets attached to the carbon compound by replacing one hydrogen atom or many atoms. So it is by this it links to the carbon compound, the functional group, by these single lines. So children, by this we'll conclude our today's class, and in my next class we will discuss on homologous series and the chemical properties of carbon compounds in my upcoming explanation in my classes. And if you have any doubts regarding my explanation, if you have any queries, then don't hesitate, drop your comments down below in the comment section, and I will try to reply to you all at the earliest. So subscribe to my channel if you haven't subscribed to be updated for every upload my classes. So I'll see you all in my next class.